As my students tell me, an open book exam is easier than a closed book exam. So don't forget that as you're filling out your course evaluations. If you think about how most QA datasets are structured, we're not asking systems to answer questions from scratch. In Squad, you get the passage in front of you with the answer somewhere in there. You just need to highlight it. Open domain question answering is a little bit harder, but you need to find the answer in Wikipedia. You still have access to Wikipedia. Is that fair? We don't let humans bring all of Wikipedia in when they take the SATs. One thing that we did in the Efficient QA competition, see the link in the description, was to try to level the playing field by limiting the amount of information the systems could store. For example, the overall system couldn't be more than 6 gigabytes. Many systems did some sort of pruning for an open domain question answering system, but is that the most efficient way to do it? Perhaps you could just store what you need in the model itself. Would that be more efficient and perhaps also more accurate? Well, that's possible now with huge models like BERT and the whole panoply of large language models. One descendant of BERT, also from Google, called T5, can generate text and do many different natural language processing tasks, including question answering. Thankfully, Google made it quite easy to try out the system. Check out the link to the collab down below. We won't go into the details of the model, but the training objective looks a lot like BERT. But rather than masking individual tokens, it tries to complete missing spans in the original text. This is a little bit like SpanBERT that we talked about before. So instead of just predicting a random 15% of tokens, you need to fill in multi-word slots. And this makes a lot of sense. Think about what happens when you have a question on, say, Jeopardy! Like we talked about for Watson, the first step is to try to find the lexical answer type. So in some sense, you're filling in the blank here. In 2001, became the shortest NBA MVP in history. But you have additional information. That blank needs to be a person, a guard, and a member of the Sixers. And T5 was trained to do exactly that, fill in the blank. It saw sentences that looked like this example from Wikipedia, and it's able to figure out that Allen Iverson is the right answer. And it mostly works fairly well, at least on the most common answers. And there are other models that can do something similar, models like GPT3, which won our course competition last semester. Again, link in the description. But these are still very early days. I haven't seen a careful comparison of closed book and open book question answering systems. Project idea there. So take what I say next with a little grain of salt. So let's talk about the pros and cons of these generative models. Again, much of this is speculation based on my experience of playing around with the models. It would be great to have some hard numbers to back my intuition up here. The first reason to prefer retrieval-based open book question answering is that if you trust the underlying source, like Wikipedia, then you can trust the answer more. A human can inspect the source and verify that it does indeed answer the question. In contrast, large language models sometimes just make stuff up, hallucination in the lingo, and there's no easy way to check if there's any evidence to support it. And here's where I can't back up my guess, but I think that generation will struggle with less common answers. If you have a large enough pool of documents, you can focus your model on generalization rather than memorizing the long tail of millions of possible answers. But that large pool of documents in open book QA comes at a cost. The closed book assumption can be much more space efficient. But generation, because it's actually generating raw text, can make typos. In fall 2021, as I mentioned before, a GPT-3 based system took on some trivia whizzes. And it did great. But it made all kinds of odd mistakes. In Swiss German, the diminutive suffix "li" is sometimes added to words. For example, a big ol' bear becomes a cutesy-wootsy bearly. But you don't use that "li" suffix when you're doing official stuff like, say, answering questions. So the system must have learned to remove "li" from answers. So in answering a question about the religious reformer Zwingli, the system removed the suffix "li" and answered Zwing instead, which isn't the guy's name after all. But these transformations can be useful too. Remember when we needed the answer to be Italy, but our evidence only had Italian? These sorts of minor transformations aren't a problem at all for generation, so perhaps the right answer is to combine the two approaches. These large language models can probably do implicit hopping, a la multi-hop datasets, on their own. So if you get some information from a retrieval system that says something happened in Cairo with Mossad, it can probably tell you immediately that Israel and Egypt are involved. But the biggest advantage of generation-based question answering is that it can be more flexible. And while you don't need flexibility for factoid question answering, it's much more important when the answer needs to fit inside a conversation, or when the answer is more than a word or two. And these are the QA contexts that we're talking about next. This is just a single lecture from a course. YouTube likes to show you these videos out of order, but if you go to the course webpage linked below, you can see the lectures in the right order, and you can get resources like homeworks or suggested reading. You can also visit quanta.org if you want to learn about our systems for creating computers that can answer questions, where Quanta stands for question answering is not a trivial activity. If you want to help the channel, provide a big gradient to the algorithm by liking and subscribing.